Welcome to Spring LIB.
In this question, we have a standing wave on a string that is given by the expression d equals 2.4 sine 0.60x cosine 42t. And in this equation, x is in the unit of centimeter. And we're asked, A, what is the distance between two nodes? And B, gives the amplitude, frequency, and speed of each of the component waves. And finally, we want to find the speed of a particle on the string at a certain place. So part A, when we want to find the distance between two nodes, as we can see, standing wave looks kind of like this. So the distance between two nodes is half the wavelength. And how do we find the wavelength? We know this is kx, and k equals 2 pi over lambda. So lambda equals 2 pi over k. So this is equal to pi over k. Which is 5.2 centimeter. Second question asks, what is the amplitude, the frequency, and speed of the component waves? So a standing wave is a superposition of two waves, and two waves traveling in opposite directions, and each one has the same frequency and same speed. And because it's superposition, they only have half the amplitude of the final wave. So the amplitude is 1/2 of 2.4 centimeter, which is 1.2 centimeter. But the frequency and speed will be the same as d. So frequency equals omega over 2 pi. And we know omega is 42 per second. So this is 6.7 hertz. And velocity is, we know what lambda is, and we also know what frequency it is. So v equals lambda times f, which is 2df, and that is 5.2 centimeter, times f is 6.7 hertz. So this gives us roughly 70 centimeter per second. And finally, we want to know the speed of a particle at 3.2 centimeter and 2.5 second. So in order to know the speed of a particle, we need to take the derivative with respect to t. It's at x equals 3.2, t equals 2.5. And when we take the derivative, we have 42, the derivative of cosine is negative sine. So it is negative 42 times 2.4 sine 0.6x sine 42t. And when we plug in the numbers, we have negative 42 rate per second times 2.4 centimeter times sine 0.x times 3.2, and sine 42 times 2.5. This gives us 92 centimeter per second.